Okay, this paper, right, we're looking at is St. Andrew, Sec 4, mid-year 2017, paper 2, A-Max. And I would only be going through questions that my student had inquired. So this is question 3. Okay, question 3, right, it says that given that 6x cubed plus 2x squared minus 4x plus 7 is equal to x minus 2 in the bracket, x plus 1 in another bracket, qx plus ax plus b, where qx is a polynomial. Find the values of a and of b. Okay, you could get question 3 part 1 correct, am I right? So you should get your A. So I will not be dwelling on your part 1 since you got it right. I'll go straight to part 2. Part 1, you says that your A is 16 and your B is 23. Okay, you should get this answer for part 1. So since you could do part 1, right, I'll not dwell on part 1. I'll go straight to part 2. So since you got your A and B, right, you can rewrite this as your 6x cubed plus 2x squared minus 4x plus 7 is equal to x minus 2 and x plus 1 qx plus your 16x plus 23, your A and your B. Then, because you find your A and your B, right, they ask you, hence, state the remainder when this fellow here, which is this fellow here, 6x cubed plus 2x squared minus 4x plus 7 is divided by this guy. So x minus 2x plus 1, right? If you were to expand, right, you will get x squared minus x plus minus 2. Okay, the question is asking, right, state the remainder when this polynomial is divided by this. So if I have to divide every term, right, by my x squared minus x minus 2, right, I'll end up with 6x cubed okay, when this term is divided by this, you'll end up with qx plus 16x plus 23 over x squared minus x minus 2. So this one is your remainder and factor theorem, right? Okay, the quotient of this and this is equal to divisor plus remainder. So my remainder, right, would be 16x plus 23. So your remainder is equal to 16x plus 23. That is your remainder. This is what the question is asking. Hence, state the remainder. So 16x plus 23 is the remainder. Any question with regards to question 3?
No.
No. Okay, no question. I'll move on. Okay, next we're going to take a look at this question. This question 4, part 1. So I'll only be going through part 1 with you. It says that sine A is equal to minus 3/5. And your cosine B is minus 5/13. A and B are in the same quadrant. So can you tell me which quadrant is A and B in?
Quadrant.
Which quadrant is A and B in?
Right.
First, second, third, or fourth?
Third quadrant.
Which one?
Third.
Third quadrant. Very good. Because the third quadrant, sine and cosine are negative. So this is your A, 3/5. This part is negative, 3/5. So this part is negative. So you have your sine A and your cos A. Cos A would be negative 4/5. Tangent A is positive. Three-quarter is your tangent A. How about your cos B? Cos B, right, is 5/12/13. Okay, -5. Cosine is adjacent over hypotenuse. So here's -12. Pythagoras theorem, you can get your -12. That is your cosine B. Sine B would be -12/13. How about tangent B? Tangent B would be opposite over adjacent 12/5. Okay. So you have your sine, cosine, tangent. Then they ask you to evaluate without using calculator your cosine half A. Your cosine half A, right? You got to use this formula, half angle formula. Yeah. Cosine 2x is equal to 2 cos square x minus 1. This is your cosine A. So 2 and 2 cancel, this is your cosine A. Cosine A is -4/5. 2 cos square half A minus 1. So you rearrange, you make cos square half A or cos square A, cos square half A, the subject. Your cos square half A, you will get 1 over square root 10. Okay, if not, let me do slowly. This one bring over is 1 plus this guy, right? One bring over is plus 1. 1 minus this guy. 1 minus this guy is 1/5. Okay, 1/5 divided by 2, right? It's times half. Okay, so this is 1/10. So cos square half A is 1/10. So cos square, cos half A, right, would be square root of this 1 over square root 10. Okay, but your 1 over square root 10 is not applicable because, right, your A over 2 is in the second quadrant.
And so can you explain this question again?
This part, explaining still at here. Well, I haven't finished explaining. I haven't finished explaining. We no space to write. Actually, I don't like Zoom picture because run out of space to write very fast compared to whiteboard. Okay, we'll just make do. Okay. So cosine half A, right? You end up with this. I think getting this no problem. Just square root this guy. But this part, right? This guy is not applicable. Okay? This value is not applicable because your A over 2 is in the second quadrant. You see, your A is in the third quadrant, right? Third quadrant, right? That means your A is between 180 to 270. A over 2, right, is between 90 to 135. 90 to 135 is the second quadrant. Second quadrant, right? Second quadrant cosine will be negative. So positive, you have to reject. Understand? You understand? A over 2 is in the second quadrant using this logic. Clear for part 1?
Yeah.
Part 2, no need explanation, right? Part 2, you never indicate you couldn't do so. Part 2, you're okay, right?
Yeah.
Okay. Then part 2, I will not go through it. Okay, let's move on to the next question. This is question 5. Question 5, it says that the diagram shows part of the curve y is equal to ln square root x minus 4. So this is your y is equal to ln square root x minus 4. This is the curve. Point P is on the x-axis. Point Q is on the curve. Point R is on this point, 6, 0. PQ is perpendicular to the x-axis. So this 90 degrees here. And is Q units in length. So this Q units in length. Show that area A, the area of triangle PQR, is in terms of Q, right? Is this okay? First, you have this equation here, right? So you have your y is equal to ln square root x minus 4. So your P, right? You do not know the x coordinate of P. You only know that Q, the y coordinates of Q is your Q. Correct? The y coordinates of Q is your Q. So I have to substitute y is equal to Q. Therefore, your ln square root x minus 4 is equal to Q. So square root x minus 4 is equal to e to the power of Q. Okay. Then I square both sides. E to the power of 2Q. So x is equal to 4 plus e to the power of 2Q. That's your x. So coordinates of P, right, is equal to 4 plus e to the power of 2Q. And 0. These are coordinates of P. How about coordinates of Q? Coordinates of Q would be 4 plus e to the power of 2Q and Q. Okay, coordinates of Q, coordinates of P. So now I have the coordinates, right? Correct, now I have the coordinates, right? I need to find the length of RP. Okay, length of RP, right? The length of RP is just the difference in the x coordinates for this. 4 plus e to the power of 2q minus 6. So I'll end up with e to the power of 2q minus 2. So the length of RP is this. I have the length of RP. So the area of this triangle, right, wouldn't that be half base times height? Half base times height. So I end up with this. So you'll get this. Clear for part 1.
Yeah.
Okay, part 2. So I just proven this is my A. So part 2, they say that the line PQ moves parallel to the y-axis. In the line PQ moves parallel to the y-axis in such a way that the point P moves along the x-axis and point Q moves along the curve. I see. That means, right, you'll become like that. It moves along the curve, moves along the x-axis, then this line is still parallel to the y-axis. This is what it means. Okay. The length of Q increases at a rate of 0.2 units per second. So that means they can move this way also. The length of Q increases at a rate of 0.2 unit per second. So dq dt is equal to 0.2. Find the rate at which A is increasing at the instance when Q equal to 9 units. So your A is equal to half Q e to the power of 2Q minus 2. Then your dA dq will be equal to this one, right? Your A, right? Your A, you can rewrite it as this. Q e to the power of 2Q over 2 minus Q. Top degree, this is your A. You open the bracket, you get this. This is your A. Then you differentiate A with respect to Q. You differentiate A with respect to Q, right? You will get Q over 2 e 2e to the power of 2Q plus e to the power of 2Q and half, then minus 1. You differentiate Q is 1. This step, okay. This one you apply your product rule. You keep Q over 2, differentiate this value, you get this. Then I keep this value, right? I differentiate Q over 2, I get half. Clear? dq, dA, dq. Then you simplify further, right? You can take out your e to the power of 2Q. You take out e to the power of 2Q, you have Q plus half. Then minus 1 is here. This is your dA, dq. Okay? Then dq dt is 0.2, right? So when Q is 9, so I substitute Q is 9. I substitute Q is 9 inside here, right? My dA dq. dA dq, you will get 19e to power 18 over 2 minus 1. Okay, when q is 9. When q is 9 is e power 18. Q is 9, right? 9.5. 9.5 is 19 over 2. Okay, you get this guy, dA dq. Then your dA dt, right? The rate at which A is increasing, right? So they're asking for dA dt. dA dt will be dA dq times dA dq multiplied by dq dt. Then you can get the answer already. The answer is 125,000,000 units per second. How much 0? 246 units per second. You understand how I get this?
Yeah.
Because dA dq already have it. Then dq dt you also have it. Just multiply it. You get this. Okay, you know what I mean.
Yeah.
Yeah. Okay. Okay, the next question is question 6, part 2. That means you managed to find your value of A, correct? Your A is 7.
Yeah.
Okay, you got A is 7. The curve for which dy dx equal to A over 1 minus 2x squared plus 1, where A is a constant and x is not equal to half, is such that the tangent to the curve at 1 and minus 3 is parallel to the line y minus 8x plus 20 equals 0. Find the value of A. So you managed to find the value of A. So your A is 7. In other words, your dy dx is equal to 7 over 1 minus 2x squared plus 1. Okay, this is your dy dx. Explain whether this curve is a decreasing or increasing function. So when x approaches infinity, right? When x approaches infinity, your dy dx should be equal to 7 over infinity plus 1. Oh, you understand this working? Because when x is infinity, okay, this will be negative infinity, isn't it? The one in the bracket will be negative infinity. Negative infinity, I square it, that will become positive infinity. So 7 divided by infinity plus 1. So 7 divided by infinity, right? This will become very, 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 very small. So your dy dx is equal to 1. In the long term, dy dx is 1. So since dy dx approaches 1, right? Approaches 1, your dy dx is greater than 0 for all real x. You need to understand what I'm writing here. Okay. You have to understand what I'm writing here. Because the rate of change, right, the gradient, right, is approaching 1. So your dy dx is greater than 0 for all real values of x. So curve is an increasing function. So the curve is an increasing function for part 2. Part 3, no need me to show you the steps, right?
No.
Part 3 you could do. So just only part 2. Okay. Then we move on to question 9. Okay, question 9. Answer the whole of this question on a sheet of graph paper. Part 2 and part 3. So you draw the graph. Okay, it is known that x and y are related by this equation. Okay, where p and q are constant. So part 1, you managed to draw the graph. Then you are supposed to use your graph, right, to estimate the value of p and q. So you will have y squared. Okay, let me write out this. Q bracket y squared minus p is equal to p square root x. Then you plot square root x against y squared, or y squared against square root x. Okay, you plot y squared against square root x. Okay, then this one, right, your qy squared minus qp is equal to p square root x. So your qy squared is equal to p square root x plus qp. So your y squared is equal to p over q square root x plus p. So isn't this y equal to mx plus c? Because you plot x squared, y squared against root x. Correct? You plot the straight line graph, y squared against root x. You plot y squared against root x, you'll get this straight line here. Right? You get this straight line here.
Yeah.
Then, but the straight line you plot, right, is actually y squared against square root x. That means the gradient of the line you have drawn, right, is p over q. And your y-intercept is your p. You understand what I mean?
Yeah.
So you have to find the gradient of this line that you have just drawn. So the y-intercept is 2. The gradient you have drawn will be, difference in here will be 4.0516 divided by 3. Okay, that will be the gradient. So the gradient you have drawn, right, is actually p over q. So the gradient you have of the line, right? So the line you have drawn, you have a gradient. The gradient is 1.35. That means p over q, right, is estimated to be 1.35. And your p is estimated as the y-intercept, right? So the y-intercept is actually at 2. Y is 2. So p is 2. So your p is 2. Because your y-intercept is 2. So 2 over Q is equal to 1.35. Q is equal to 2 over 1.35. Okay, that is Q is 1.481. This is how you use the graph to solve your P and your Q. Basically, you need to transpose this equation, right, into this equation here, where you have your y square and your root x. Then you have your big Y. Your big Y is your y square. Big Y is equal to m big X plus c. Y equal to mx plus c. And your big Y is y square. Your big X is your square root x. Your P over Q is your m. That's the gradient. Then P is the y-intercept. You need this working in order to see, right, the gradient is what, and the y-intercept is what. That means it's your algebra manipulation. If you can't do part 2, right, that means it's your algebra manipulation. You didn't manage to algebra manipulate this, right, until you get this. Oh, you understand the logic?
Yeah.
Cannot. So am I right? This part you didn't manage to produce this.
I only thought that the ky square equals to p root x plus qp.
Py square.
The line before the y square.
Here.
Yeah.
Because you need to make y square the subject. Then it'll be much easier to see. How come you need y square to be the subject? Because the graph, right, is y square against root x. Because when you plot equation for line, right, it's always y equal to mx plus c. And right now you know that your y, right, is actually your y square. And your x is square root x plus c. That means the y-axis, the y-axis is y square. The x-axis is square root x. That's how you get a straight line. So you need to change this expression here, right, into this form. Into this formula. Then you can see your m is what? My m is this guy here. And my y-intercept c is this guy here. That means this guy is p. Then you look at your graph. That's what they mean by use your graph to estimate. Then you got to look at the graph that you're plotted. What is this part here? Oh, that's your p. Then you find your gradient. Will rise over your run. Rise over run is your gradient. So once you get your gradient is your m. Your m is your p over q. Gradient. 1.35, I got it from the graph, by the way. Just now, graph. Okay, for part 2, you understand, no?
Yes.
Okay, part 2, if you understand, I move on to part 3 now. Part 3, it says draw a straight line, right? Draw a straight line for what purpose? Find the value of x which satisfy that equation there. Okay, what is the equation? The equation is 2p plus q root x equal to 10q minus 2pq. So you have to write out this expression here. So I have my 2p plus q square root x is equal to 10q minus 2pq. Okay. Then after that, same thing, I manipulate this equation again. Okay, how am I going to manipulate this equation? You have to expand here. This will be 2p root x plus q square root x is equal to 10q minus 2pq. Then after that, I'm supposed to make y square my subject, right? Okay, y square is this guy, p over q root x plus p. So I will divide by 2q on all the sides. So I divide by 2q, right? So I have my So I'm going to divide by 2q. I have p over q square root x divide by 2q. I will have root x over 2 equal to 5 minus p. Okay, I divide by 2q. Divide by 2q. I'll get this equation here. Okay, I do this so that, right, this term will appear. P over q root x. P over q root x appear already. Plus my p. I'm going to bring my p over, right? Is equal to 5 minus root x over 2. So this whole thing, right, is actually my y square. Can you see? Y is equal to mx plus c. So the straight line you're going to draw, right, is big Y is equal to minus half big X plus C. This is a straight line you have to draw. Then you draw this straight line, right? The intersection, right, is the solution for this equation. Okay, the intersection, if I draw this line, okay, plus 5, I draw this line. So the intersection is this one, 1.62. Then root x is 1.62. So from the graph, right, square root x is 1.62. So x is equal to 2.6244. Understand now?
Yeah.
Yeah. Actually, graph is the marks, right? Is not so hard to get. Graph is quite kind of question where the marks I would say is quite easy to score for graph. It's just about manipulating the equation and draw the straight line and use the graph to solve part 3. Usually it's about 10 marks, so it shouldn't be too hard to do compared with integration. So you try to score full marks for your graph question if you can. Okay?
Yeah.
Okay, you're okay. Let's move on. Okay, the next question is question 10. Your coordinate geometry, question 10. Okay, question 10. The diagram not drawn to scale shows a rhombus PQRS, where P is 4,1, Q is on the x-axis. Q is on the x-axis, let's call it x0. Okay, the coordinates of Q is x0. And R is 8, 5 is given. The diagonals meet at M. So you can find the coordinates of M immediately. Midpoint of R and P. Okay, midpoint of R and P is your coordinates for M. So your coordinates for M is 6, 6, 3. Okay. Midpoint, 8 plus 4 divided by 2 is 6. 5 plus 1 divided by 2 is 3. So immediately you can find your midpoint. Then they are asking for Q and S, right? The coordinates for Q and S, right? So before you can find coordinates for Q and S, right, you already got coordinates for your M. So right now, right, you have to find the coordinates of Q. So you have to find the gradient of PR first. Gradient of PR is 1. Okay, let's find the gradient of PR. Because these are rhombus, right? They are perpendicular to each other. Okay, because it's a rhombus. Because it's a rhombus. If it's not a rhombus, they are not perpendicular to each other. Okay, then your gradient of PR of PR is 5 minus 1 divided by 8 minus 4. That's equal to 1. So your gradient of SQ is equal to minus 1. Because they are perpendicular to each other. So since I have the gradient of SQ, right, I have the equation of SQ. Equation of SQ is y minus 3 equal to minus 1 multiplied by x minus 6. So you tidy up this expression, your equation of SQ will be y is equal to minus x plus 9. That's the equation of SQ. Once you have equation of SQ, you can find coordinates of Q already. Your coordinates of Q, right, is when y is 0. So when y is 0, minus x plus 9 is equal to 0. Your x is equal to 9. Therefore, coordinates of Q will be 9, 0. Okay, coordinates of Q is 9, 0. Okay, and then from here, right, you need to know that the translation, right, from Q to R, right, is the same translation from P to S. Because this is a rhombus. These two lines are parallel. Not just parallel, same length. Your SP, the length of SP is equal to length of RQ. Oh, because it's a rhombus. So since the length is the same, right? Okay, translation of P to S is the same translation from Q to R. Oh, you understand this statement? You know translation? Okay, because I don't know the coordinates of S, but now I know the coordinates of Q. So I can find out the translation from Q to R, right? It's basically, right, x-axis, right? X-axis minus 1. Okay, the y-axis is plus 5. This is the translation. Minus 1 at x, plus 5 at y. So minus 1 at x, my coordinates of s, right? Minus 1 at x will be 3, plus 5 at y. 1 plus 5 is 6. So coordinates of s is 3, 6. Understand?
Yeah.
Or you can rewrite it as coordinates of s is equal to coordinates of P plus translation of Q to R. So you have 4, 1 plus minus 1, 5. So 4 minus 1 is 3, 1 plus 5 is 6. That's the coordinates of S, 3, 6. Oh, any question in regards to part 1?
No.
Actually, coordinate geometry, it should be quite easy for students to score on, because it's not a hard topic, coordinate geometry, comparing with calculus. Okay, A max or those topic in front, right, is meant to help student to get the marks. So coordinate geometry, you have to score full marks also in order to help yourself well. Okay, then after that, part 2, right? Part 2, it says that given that T is a point on QS, P is a point on QS. Okay. QS produce, okay, such that area QRM to the area of QRT is 1:9. Show that the coordinates of T is -18, 27. So you have the area of QRM. Area of QRM is equal to area of an area of QRT half QT times Rm. Okay, QT times Rm. Because T is somewhere here. Okay, QT, you don't know where is it. But you know it's QRT. So since the ratio is 1:9, right? So half times QM times Rm over half times QT times Rm is equal to 1/9. So Rm can cancel, right? So you will have your 9QM is equal to QT. Okay, you'll get this. 9QM is equal to QT. Okay. So length of QM. What's the length of QM? Length of QM you can find, right? Length of QM is 3√2. Or length of QM, I won't do on it. Length of QM, you should know how to find, right? Correct?
Yeah.
Given the coordinates. So length of QM, I just straight away tell you the length, 3√2. So you have the length of QM, you will have the length of QT also. Correct? So length of QM is equal to 3√2. So translation of Q to M, right, is -3, 3. Oh, -3 and +3 here. So -3, 3, that's the translation. So translation from Q to T, right? Will be 9 times of this. Okay? 9 times of this. Because I found out it was 9 times of this. So coordinates of T, right? Coordinates of Q plus this translation. So try the Q plus that translation, right? You have minus 18, 27. Oh, understand? Huh? Can you understand part 2?
Okay.
Okay, part 3, right? Since you have all the coordinates, right? Just apply the formula. Lah. You know the formula? Half
Is it the
4,
shoelace
1,
method?
90, what?
Is it the shoelace method?
English method.
Shoelace.
Shoelace method, yeah, shoelace method. Because you have the coordinates, just use the shoelace method, you'll get 108. Because you have the coordinates, no problem finding quadrilateral, right? The area.
Yeah.
Yeah. Any question for question 10?
No.
No, no, I move on to next question. Okay, next question is question 11. Part B. I think it's linked to A, right? Let me see. Yeah, it's linked to A. Because the fx is this guy. How is linked to A? So the denominator is your fx. So that means that means x plus 2 is a factor of this guy. Then they want it in partial, right? Correct?
Yeah.
So you'll end up with, let me see, fx equals 0 has exactly one real root. So anyway, x plus 2 is a factor of fx. Okay? So you'll end up with, let me see, has exactly one real root. So your 8x cubed plus 71 over, okay, you should have, right, x plus 2 then 2x squared minus 6x plus 9. You should have this fellow here.
Yeah. Then start with this.
Then in partial, right? So in partial, before you do in partial, right, you got to do the long division to get your quotient and the remainder. Because you see, 8x cubed, 2x cubed. This is an improper fraction, if you notice. Okay, this guy is an improper fraction. Then here we have 2x cubed minus 2x squared minus 3x plus 18. Okay, this part, no problem doing here, right?
No.
If no problem, you will get this remainder. Okay, your remainder is 8x squared plus 12x minus 1. This is your remainder. So in other words, they want you to express this guy in partial, right? You should have 4 plus 8x squared plus 12x minus 1 over this guy here, right? This guy is actually this guy here, x plus 2, 2x squared minus 6x plus 9. You should have this. Then you only need to do partial fraction for here. For here. So here you will have 4 plus a over x plus 2 plus bx plus c over 2x squared minus 6x plus 9. Because the 2x squared minus 6x plus 9, right, cannot be factorized, by the way. Okay. Then, like that, you know what to do. You know how to continue doing from here.
Yeah, okay.
You know how to continue doing already, right?
Yeah.
Then you will end up with a is equal to 7 over 29. B is equal to, I write out the answer here, then you try out first, see you get the same answer. Okay, you try first, see you can get this 3 answer for 11. You still got 14 now. I go through 14 first.
Okay.
You still got 14, need me to go through. I go through 14 first. Then I'll let you have time to do. You write down the answer for ABC first. Somewhere near there. You can copy this thing, just the last part, and the answer for ABC. Then see you can find your ABC or not. Copy finish already?
Yeah, okay.
Can now. Okay, question 14, circle part 1 and part 4. So part 2 and part 3, okay?
Yeah.
2 and 3, okay. 3 you can explain. Explain whether second circle lies inside the first circle.
But I feel like I will find the radius.
Correct, radius.
Then I feel like the second circle lies inside the circle as the radius is within the diameter of the first circle.
Cannot. Since the radius of second circle is root 5, center. Radius of second circle smaller than radius of the first circle, then can already. Okay. Then part 1, right? Show, okay, diameter AB where A is the point 6 minus 2. Show that the equation of circle is this. Diameter is AB. So you find midpoint of AB first. If they tell you diameter is AB, right? So midpoint of AB is the center of the circle. Okay, midpoint is 92. 6 plus 12 divided by 2 minus 2 plus 6 divided by 2. So you have midpoint of AB. Midpoint of AB is the center of the circle. So you have center of circle, 92. If you have center of circle, right, you can find radius, right? Radius will be OA or OB, either one. Okay, length of OA. You have coordinates of O, you have coordinates of A. So finding length of OA shouldn't be a problem, right? Correct? So you have 9 plus 16, go to 5. You understand this part?
Yeah.
Okay. 9 minus 6 square plus 2 square. So you have radius is 5. If you have the radius and you have the center, equation of circle will be very easy to find already, right? X minus 9 square plus y minus 2 square equal to 5 square. Isn't this the equation of the circle? So you've shown already for part 1. Okay, part one.
Yeah.
Okay, part two, find the equation of the tangent. I need to write down the equation of tangent over there first because I think I might need the answer to do part four. Okay, part two. Part two, the answer is equation of tangent at B. Y is equal to minus 3x over 4 plus 15. You got the answer. Then part three, a second circle has equation blah blah blah. Explain whether the second circle lie in the first circle. It lie in the first circle. Okay. Find the range of values of m such that the line y equal to m meets the circle. So when x is equal to 9, y minus 2 square is equal to 25. If x is 9, y minus 2 square is 25. So y minus 2 is either 5 or minus 5. So y is either 7 or minus 3. So range of values of m will be minus 3 and 7. Because y is equal to m, what? Because if it says y is equal to m, this is a range meets the circle. Okay? Hence, take the value of m such that the line is a tangent to the circle. Hence, state y equal to minus 3, y equal to 7. So m equal to minus 3, m equal to 7. Since y equal to m is the line. Oh, okay, part 4.
Yeah.